Hello everyone. So in this video I'll be covering a little bit about derivation rules, but in order to start out we need to of course know what a derivative is. So in order to demonstrate I'm just going to write or draw a graph over here which we'll call y equals f of x. So it's going to be the graph of our function f of x. Now, what the derivative essentially tells us is what the rate of change for each point is. Now, it's tiny bit more complicated than that, because if you think about it, it doesn't necessarily make sense to call the derivative as a rate of change at a certain point, because when we are measuring rate of change, we need to have 2 points, 2 reference points, in order to determine the change. But the reason for that inconsistency is because we are essentially talking about limits. Because if you have read anything about derivatives, you will know that the definition of it is something that looks like this. So we have limit as h approaches to 0 of f of x plus h minus f of x all over h. So what this essentially tells us is we are taking a point here, so let's call it x, and we are taking another point with a difference. So the difference here is essentially h. And what we are doing is we are taking the difference of the y-coordinates, the f of x plus h minus f of x, so it's just going to be, let's see, it's just going to be this little part here. And then we're basically dividing this by our difference. So it's just the equation of how we determine the angle of a linear function. If you remember the equation delta y over delta x, perhaps, now it probably makes a little more sense, because it's basically just the derivative or the difference of the y coordinates over the difference of the x coordinates. That's just going to give us the angle at which this line kind of intercepts these points. And what the derivative is we're letting the difference go more and more to 0. So we're letting it approach 0. This means that our 2 points, points here on the x-coordinate, or the x-axis, we're basically letting them go closer and closer together, and essentially we will get pretty much a tangent that'll kind of determine us the I guess you can say in quotation marks approximate angle for the tangent that goes through x. So that's going to be the derivative of a function at x. So now we can go through our first derivation rule, and it's something that you usually get taught quite early on in mathematics, and it's called the power rule, which I think many of you have seen. It says that the derivative of a function for which we have a base, x, and an exponent n, where n is pretty much any constant that you want, any arbitrary constant, we can generalize this, the derivative of x to the power n, as n times x to the power n minus 1. And I just want to denote that n is within the real, is a real number. So this will pretty much always hold, but to kind of familiarize with this derivation rule, we can take a few examples. But just to note a few other ones, if we have the derivative of two functions that are added together. So, for example, the derivative of f of x plus g of x, then this will be f prime of x times, or plus g prime of x. Now, the reason for this is because when we derive f of x plus g of x and we use the property or the definition of a derivative, you'll notice that you kind of get two limits that are added on together. But two limits that are added on together, for which we have pretty much the same limit, well, we can essentially just fuse them into one, and as such, this property will hold. Another one is the derivative of a constant multiplied by a function. So the derivative of a constant multiplied by a function we'll call f of x is just going to be the constant multiplied by the derivative of the function. So these two properties are quite important, and I suggest actually trying to derive these two properties by yourself, because it's actually quite interesting if you use the properties or the definition of a derivative. Now I've already gone through the first one, but you can try to actually try to prove this second one, which is actually quite nice. But to familiarize with this derivation rule, we can take a few examples. So let's say that we have the derivative of, let's go with an easy one. Let's say we have the derivative of x to the power 4. So how do we solve this? Well, we can just use our first property here. There's no need to use our two other properties that I've denoted here. So the derivative of x to the power n is going to be n times x to the power n minus 1. So this derivative over here will essentially just be n, which is 4 right here. So 4 times x and then multiplied by, or raised to the power n minus 1. So our n is 4, so n minus 1 becomes 3. So the derivative of x to the power 4 is going to be equal to 4x cubed. Okay, so how about we derive this function then? Well, this one I recommend you guys to try yourself, but I'm going to directly be presenting the solution. So if you want to solve this on your own, please pause the video right now. But yeah, so how do we solve this? Well, we can use our third property. The derivative of a constant multiplied by f of x is going to be the constant multiplied by the derivative of the function. So in other words, we can, here our constant here is 4, so we can just move that out here, so it's going to be 4 times the derivative of x cubed. And here, the derivative of x cubed we can actually figure out by just using our power rule again, which is just going to be, well, our n is 3, so it's going to be 3 times x squared. So it's 4 times 3x squared, which is equal to 40 or 12x squared. Sorry. Okay. So for our last example, so I'm just going to denote the answer here, but our last example, which I'll denote right here, is going to involve all of the properties that I've given here. So if you if you manage to solve this, then I am pretty sure that you have gotten the hang of this entirely. So let's say we have 10x to the power 5, 4x cubed plus 4x cubed plus 2x. Yeah. Let's say we have this derivative and we want to solve it. So what can we do? Well, try to figure out this one out by yourself using these three properties. I know that my style of writing might not be the best, but if you know the properties that I've shown here, you should technically be able to solve this. And if you do, you will have mastered pretty much the power rule for these types of questions, because that's pretty much all of it, I guess you can say. So if you manage to master this, you pretty much master the ability to derive any sort of polynomial equation. So now we have the second part of this video, and it's going to be about the chain rule, which might be a little more advanced than the power rule, because it's about inscribed functions. So let's talk a little bit about inscribed functions. Now, an inscribed function is basically any function that is within a function. So here we have, for example, f of g of x. Now, for example, if we let f of x be equal to sine of x, and we let g of x, which is our inside function, to be x squared, then f of g of x will essentially just be we will essentially just be replacing our x here with g of x. So f of g of x is just going to be, let's see, so f of g of x is just going to be equal to sine of g of x. So because we have sine of x here, and we replace x with g of x, so we're going to have sine of g of x, and that's just going to be equal to sine of x squared, because g of x equals x squared. So it's essentially sine of x squared. So here we have an inscribed function, and I mean sine of x is already an inscribed function if g of x equals x. So you can say that pretty much any function can be described as an inscribed function, but let's just hold it here for now. So I forgot 2 there, but so let's say we have this inscribed function right here, so sine of x squared. How would we derive this function over here? Well, we can't use any of our we can't start off with any of the rules that we currently know, basically the power rule or something like that. So we need something called the chain rule, as I stated from the beginning. And what the chain rule says is that the derivative of an inscribed function, so for example, the derivative of f of g of x, oops, so the derivative of f of g of x can be written as the derivative of, or perhaps I should say f prime. So f prime is essentially just the derivative of f of x. I'm not exactly sure if you've seen this notation before, but it's just going to be the derivative of the outside function, and we let that derivative, or we let the input of that derivative be g of x. So f prime is just going to be the derivative of sine of x in this case, and the g of x is just going to be the input. And we want to, and the derivative, and we multiply that by g prime of x. So g prime of x is just the derivative of g of x. So g prime of x, right there, So we can use this property to actually solve our initial equation. So sine of x squared, the derivative of that is just going to be, let's see, so we have the derivative of sine of x squared over here. So in this case, you'll notice that our outer function, as we said before, is sine of x, so it's going to be sine, and our g of x, which is our inscribed function, is essentially just x squared. So let me demonstrate. So f prime of x. Okay, so the derivative of sine of x, so our f of x. Well, the derivative of sine is cosine, so I'll be denoting it here. And our input is g of x. So the derivative of sine is cosine, and we want to have g of x be the input, so it's going to be cosine of x squared. Let's see. So cosine, okay, that's not very pretty, but let's see. The cosine of x squared, and we want to multiply that by the derivative of g of x. So it's going to be the derivative of x squared, which is 2x, if you use the power rule that I demonstrated earlier on. So cosine of x squared times 2x, which is 2x cosine of x squared. Okay, so that's going to be our correct answer. 2x times cosine of x squared is the derivative of the function sine of x squared. And it uses the so-called chain rule that we have used over here. And that's one example. But how about we go to another level with this? So let's say we have two. Let me think. So how about we have 2 sine of x, sine of, let's say, okay. So how about we have the derivative of 2 sine of x cubed plus, let's say, 3 times the cosine. Okay, 3 times the cosine of x squared. So I suggest solving this. Of course, every single problem that I present here, I do recommend you to solve by your own, because mathematics is usually not a subject where you pretty much listen and you know immediately about what you're doing. Instead, it's more of a subject where you kind of need to do your own problems in order to become better at it. So here's our second example. The derivative of 2 sine of x squared plus 3 cosine of x, or 2 sine of x cubed plus 3 cosine of x squared. And so I challenge you guys to solve it, and I'll probably post the answer somewhere in the comment section, because it's probably going to be it's probably going to take a little bit a little time to solve this in this video. So yeah, I'm going to probably post a solution in the comments, and yeah, I hope you guys managed to get the correct answer. Okay, so now we go on to the last part of this video, and it's about the product rule. So if you manage to actually be able to master all of these three derivation rules, you should, technically speaking, be able to pretty much derive any sort of function you want, because pretty much all functions are kind of are pretty much a combination of these three different these three different rules, you can call them, where you can pretty much use these three rules to solve them. So let's go on with the product rule. Now there's another one called the quotient rule, but that's not very important, or you can pretty much derive it with the product rule either way, so it's not 100% necessary, I would say. But let's talk about the product rule. Now, as the name suggests, the product rule essentially is just a derivative where you have two functions that are multiplied together. So to demonstrate this, two functions that are multiplied together. So we have f of x and we have g of x that are multiplied together. So f of x times g of x is the multiplication of two different functions. And the product rule essentially just tells us or generalizes the derivative of these types of functions. So the derivative of f of x times g of x. Yeah. So the product rule. We have the product rule. So the product rule essentially states that the derivative of f of x, a function, multiplied by another function, can be written as the derivative of f of x times g of x plus f of x times g prime of x. So it's the derivative of f of x multiplied by g of x added on with f of x times the derivative of g of x. So there shouldn't be too big of a problem to grasp. I'm going to take a few examples to make you able to kind of familiarize yourself with these types of derivatives. So let's start off with something I guess you can say a little bit easier, on the easier side. So let's say that we have f of x being equal to, let's say, x cubed. And let's have g of x be equal to, say, sine of x, because that's pretty much the only function that I can come up with right now. But the derivative of, so we want to solve the derivative of x cubed times sine of x. So what is the derivative of that? Well, let's use the our property of the product rule. So our f of x is, in this case, as I denote here, x cubed, and our g of x is sine of x. So we want the derivative of x cubed times g of x, which is sine of x. And we add that on with f of x, which is x cubed, and the derivative of sine of x. So d over dx times d over dx of sine of x. So this is going to be our derivative. And as you can see, it's actually a much... we actually made a function, the derivative of a function, become much easier to do, because we know the derivative of x cubed and we know the derivative of sine of x. So the derivative of x cubed is 3x squared according to the power rule. We basically move that exponent down to as a coefficient and we subtract 1 by it. So it's 3x squared multiplied by sine of x plus x cubed multiplied by the derivative of sine of x, and the derivative of sine of x is essentially just cosine of x. So I'm just going to simplify this as, let's see, 3x squared, so that's the derivative of x cubed, So 3x squared times sine of x plus x cubed multiplied by the derivative of sine of x, which is just cosine of x. And that's going to be our derivative. So that is a function that describes us the rate of change of our initial function x cubed times sine of x. But this is, of course, only a quite easy example. So how about something a little harder? So how about we have, let's say we have sine of x squared, sine of x cubed, actually. Sine of x cubed times, let's say, x squared times cosine of x squared. So keep in mind that all of these problems, I haven't actually planned these beforehand, but they should still come out actually not that bad, I would say. But in this case, which will be my final example for today, I'm just going to go through this derivative with you guys. Make sure to pause it in order to try it out yourself. But if you manage to actually get a hang on the chain rule, the power rule, and the newly introduced product rule, you should be able to solve this. Actually, I don't think you should. I don't think it's actually that hard. I haven't tried it yet, but let's see what we get. So let me see. Let us say that our f of x, whoops. So our f of x is equal to squared. And let's say that our second function, g of x, is essentially just sine of x cubed times cosine of x squared. So what I'm doing is essentially just calling f of x being equal to this function and g of x being equal to sine of x cubed times cosine of x squared. So this will, and now I can actually use the power rule here, because essentially just two products that are, or two terms that are multiplied together. So it's just going to be, let's say, f prime of x times g of x plus f of x times g prime of x. So f prime of x is just going to be 2x, and we want to multiply that with sine of x cubed and cosine of x squared. And we just add that on with x squared, which is our f of x. Let me make this more clear. So x squared times the derivative of g of x. So it's going to be the derivative. Wait, I probably should write down the multiplication sign as well. So the multiply by the derivative of sine of x cubed times cosine of x squared. So now, as you can see, we have just a derivative with with two terms. So what we essentially can do is just to use our product rule again to solve for this derivative. And what we need to do now is to also use our chain rule that I introduced sometime early on in this video. So let us see what the derivative of because we already know all of these terms, so we only need to evaluate this, and then we'll pretty much get our derivative. So d over dx of sine of x cubed multiplied by cosine of, what was it? Cosine of x squared. So here we have it, and we'll just use our product rule again. So it's going to be the, so here we have the property. And in this case, I'm just going to call this f of x. So this is going to be our f of x. And this is going to be our g of x. And we can just apply the rule. So the derivative of sine of x squared, x cubed. And we have g of x, so that's going to be times the cosine of x squared. And then we add that on by sine of x cubed multiplied by the derivative of g of x. So that's going to be the derivative of cosine of x squared. Perfect. Okay, so the derivative of sine of x cubed, we can just use the power rule. And the chain rule. The chain rule essentially states that, as you probably recall, it helps us to derive inscribed functions. In this case, the function that is inscribed right here is going to be x cubed. And for our second function right here, it's going to be x squared. So let me just write down the chain rule. So the chain rule essentially states that the derivative of inscribed function f of g of x is going to be equal to f prime of g of x multiplied by g prime of x. There we have it. Okay. So now we can actually properly solve this equation. So we have the derivative of sine of x cubed it's going to be the derivative of our outer function, which is sine of x in this case. So that's going to be cosine of the derivative of sine is cosine, and we have x cubed, so our inner function, and we multiply that by the derivative of the inscribed function, so that's going to be times 3x squared. And because the derivative of x cubed is 3x squared according to the power rule. And you can of course also find the derivative of x cubed using the definition of the derivative. It should be possible, and it shouldn't be that hard, I think. So that's going to be the derivative of sine of x cubed, and lastly, we just want the derivative of our cosine of x squared. So we apply the same concept here. It's going to be negative sine of x squared because the derivative of cosine of x is negative sine. So negative sine of x squared times the derivative of the inside. So it's going to be times 2x. And we should have that we should get our derivative of this function right here. So let's finish it off. So let's see. Okay. Derivative of sine of x cubed, that's going to be cosine of x cubed times 3x squared. So I'm basically following this equation right here, right now. So cosine of x cubed times 3x squared times cosine of x squared. And we add that on by sine, or it's actually negative sine of x cubed, because we have negative sine of x squared. We have a negative sign over here, so this is basically the same thing. So we're going to be subtracting, in other words. So negative sine of x squared times the derivative there, so it's going to be negative sine of, or sine of x cubed actually. Oh, it's my fault. Okay, so negative sine of x cubed multiplied by sine of x squared times 2x. And that grants us with cosine of x cubed times 3x squared times cosine of x squared. Oops, okay, so times the cosine of x squared, cosine of x squared minus sine of x cubed and the sine of x squared times 2x. Now, I won't be showing the complete simplification of this, because what we've essentially done is we have evaluated the derivative of sine of x cubed times cosine of x squared based upon this particular derivative, where we basically had f of x, according to the product rule, we have f of x being equal to x squared, or I set it to x squared. You can actually set, because this is associative, so you're allowed to pretty much say that f of x equals x squared times sine of x cubed, or x squared times cosine of x squared. It doesn't necessarily matter, I just chose randomly. But in this case, we use the product rule to get this, and we ended up with this derivative, which we evaluated here, and we got some quite, I guess you can say, messy expression. But if you just plug that in to this expression right here, you should be getting the derivative of this function. So you can say that's a derivative on more on the more harder side, I guess you can say. So if you actually manage to solve that, well, I guess you now pretty much know how to apply the product rule as well. So if you actually manage to solve pretty much all of the questions that are introduced in this video, you should have no problem in pretty much deriving any function. Now, there's one little detail, or one tiny detail, that I've excluded, and that's the derivative of I guess you can say, these types of functions where you have essentially, when you divide two functions together. But this is essentially just this is essentially just two functions multiplied together. It's just f of x times 1 over g of x, right? So you can actually just use the product rule to actually derive what we call the, I think it's called quotient rule. I haven't looked up the name very properly, so I'm just going to say that it's the quotient rule. So if you're interested in that, you can actually try to derive the quotient rule by using the product rule. Well, it's not necessarily deriving, because then you need to also derive the product rule, which I'll probably show later on. But just as an extra challenge for today, before I end this video, how about you guys try to solve the derivative of x to the power x? So let me know what you think of this derivative. because it's kind of like because you can't just derive it um, using the power rule because it's a function, and we have another function here in the exponent, so it's not necessarily a constant. But yeah, that's my final challenge for today. And I'm excited to find out if you actually managed to solve it using the things that I've taught in this video. It might be a little, uh, it might actually be quite difficult, but as you actually try to solve more derivatives, these types of questions should be definitely more easier. But just a tip, try to simplify. So always try to find ways to simplify your expression, and um, you should be good to go if you, especially for this question, if you manage to find a way to simplify it. And yeah, so this is going to be the video for today. Oh, one tiny detail: the derivative of e to the power x is the same as itself. So yeah. Um, that's going to be it for today. I hope you guys enjoyed the video. I hope you have learned quite a lot about derivation rules. And yeah, I'll see you in the next one.